Hello everyone. One of the new subtopics of coordinate geometry for the June 2020 syllabus of AS level math, pure math, that is circles. Circle was studied before using the properties of circle, the geometrical properties. There were questions related with arc length and area of sector and so on. That was part of circular measure. But the new topic is about equation of a circle. In the first video, we discussed questions that were related with equation of circle. How do you convert from the general form to the completed square form? How do you look at the radius, the center of the circle, and so on? Now, in this particular video, we are focusing on 8 questions, 8 tough questions related with the different properties and equation of a circle. Now let's first review what those properties are. The first property, radius is perpendicular to tangent at the point of contact. Second property, if there is a chord and we draw a perpendicular bisector of that chord, it's necessary that that particular perpendicular bisector will pass through the center of the circle. The third property is that the diameter produces a 90-degree angle at the circumference of the circle. Now, let's start with the first question that is related to the tangent property. Let's read the question. Determine the equation of the tangent to the circle with equation such and such at the point 2,5. Give your answer in this form where a, b, and c are integers. First and foremost, we are not given the standard format of the equation of a circle, the one in which we can see what is the center and what is the radius. So one of the objective is convert to that form. Second thing, from the center to this point, you can find the you can find the gradient, and negative reciprocal would be the gradient of the tangent. And then you proceed in order to find that equation. So this is what our thinking process was. And now let's get started. First thing, completing square method. The completing square method is used in 2 different scenarios. Once in the chapter of quadratic and secondly in the circle equation. So you apply the completing square method and you get the equation of a circle. The center is 1, 2. The point at which the tangent will be drawn is 2, 5. So therefore, find the gradient of CA. Negative reciprocal would be the gradient of the tangent. The tangent point is 2, 5. Therefore, it's very easy to find the equation of the tangent. Since the examiner has specifically asked to write the answer in a particular format, we should cross multiply, take everything on one side, first the x term, then the y term, then the constant. Now, let's look at the second equation, the second question that is about the shortest distance and maybe the longest distance. Determine the distance from the point to the circle. What does the brainstorming says? Make sure to write the equation of the circle in the standard form. Find the distance from the center to the given point, which in this case is 1, 1, and then think about the shortest distance. So let's get started. Again, the completing square method. And now this time, the center of the circle, let's see what it comes out to be. It comes out to be -3, 4, and the radius is 2. So now from the point to this center, find the distance, which comes out to be something like, using the distance method, distance formula, this comes out to be 5 units. PR is the shortest distance. PR is basically PC minus the radius. So the shortest distance is 3 units. What if the examiner would have asked for the longest distance? So that would be PC plus the radius. It would be going on the other side. So therefore the longest distance would be PC plus the radius. Third question. Now we are using the semicircle property. Let's look at the question. 3 points PQR have coordinates such and such respectively. Use Pythagoras theorem to show that PQR is a right angle triangle. Hence find the equation of a circle that passes through PQ and R. Thinking process. Find the distance PQ, QR, PR. Leave the answer in the third form. If they fulfill Pythagoras theorem, that means it's a right angle triangle. Whatever is the greatest length, the point opposite to the greatest length would be the 90-degree angle. The greatest length would be the diameter. Half of diameter would be the radius. Midpoint of the diameter would be the center of the circle. One small question, too many things to think. Now, you find PQ, you find QR, no need of a calculator, that's a waste of time, and you find PR. So PR comes out to be root 100, therefore it's fulfilling Pythagoras theorem, as you can see. Longest distance is PR. Which alphabet is missing? Q. That means Q is 90-degree angle. Distance PR, half of that is the radius, which is 5 unit. And midpoint of PR would be the center of the circle. Hence, you write down the equation of the circle. Now, if the examiner would have not specified to use Pythagoras theorem, was there any other way? Is there any other way? The answer is yes. We can use the concept of gradient. We can say, take out the gradient of PQ, take out the gradient of QR, take out the gradient of PR, multiply each one of them, PQ into QR and so on. Any two gradient which gives you -1, that means there is a 90-degree angle over there. And whichever is the common alphabet, that would be the 90-degree. For example, since we know that angle Q is the 90-degree angle, that means gradient of PQ and QR will give you -1. What is the common alphabet? Q. So Q is 90 degrees. Now, tangent to the axis. A question based upon this. Find the equation of the circle that touches the x-axis and whose center is 6 minus 5. It is necessary that if a circle is touching the x-axis, then y-coordinate of the center is the radius. How do I know that? I know it because I can draw it. If I draw this equation, the distance from x-axis to the center, isn't it the y-coordinate of the circle? Yes. So therefore, x minus h whole square, y minus k whole square is equals to r square. Therefore, I plug in h and k, which is 6 minus 5. Radius is this thing. And therefore, the radius was the missing part. So radius is the y-coordinate of the center. I change this question again. Find the equation of a circle that touches the x-axis and whose center is 6 minus 5. Now think for a second. If the circle touches the x-axis, then the x-coordinate, if the circle touches the y-axis, then the x-coordinate of the radius is the center. There is a misprint over there. Again, the diagram. Distance from y-axis to center is the radius, is the x-coordinate of center of circle. X minus h whole square, y minus k whole square is equals to r square. Plug in h and k, but this time r is 6, so 6 square is 36. The chord property. Find the equation of a circle that passes through the point such and such and has a center lying on this line. So you find a chord. There is a chord between 7, 3 and 11 minus 1. This chord will intersect the other line, and it is necessary that they both would be meeting at the center. The property of chord is the perpendicular bisector through the chord would be passing through the center. The examiner has already said that they would be meeting each other at the center. That means you can find the center by solving simultaneously. So therefore, A is 7, 3, B is 11 minus 1. Find the midpoint. Find the gradient of AB. Find the gradient of the negative reciprocal of AB. Hence, you find the equation of perpendicular bisector of AB. Is this straightforward from basic coordinate geometry? Now solve this equation simultaneously with the given equation. That will give you the center of the circle. You have the center. The distance from the center to any point on the circumference is called the radius. So therefore, the radius comes out to be root 40. Center is 5 minus 3. Hence, you can write the equation of the circle. The chord property again. This time, if I give you 3 points on the circumference of the circle, there are 2 chords present. For example, a point is A, B, C. So AB is one chord, BC is the other chord. You can find the perpendicular bisector of each, solve them simultaneously, and then history will repeat itself. A circle passes through the point origin 3, 9, 11, 11. And find the perpendicular bisector of each. Look at the process thoroughly. Math is all about simplification. It's about logic. It's about writing things down in the proper order. If you cannot handle the proper ordering, you won't be arriving at the right answer. Maths is simple, provided you take every necessary precaution to do things right. The left hand side is the first perpendicular bisector. Right hand side is the second perpendicular bisector. Expand the equation. Solve simultaneously. Your choice to solve it either using substitution or elimination, whichever one you feel is better for you. You find the center of the circle. From the center to the radius, from the center to any point on the circumference, that is the radius of the circle. Tangent property again, and this is the last question, finally. A circle has radius 10 units. It passes through 5 minus 16. Now keep in mind 5 minus 16 is not the center. This is a point on the circumference. The x-axis is a tangent to the circle. Find possible equations of the circle. That means the radius is given. That is 10 units. When x-axis is tangent to the circle, y-coordinate of the center is the radius of the circle. This we have gone through a little bit before. Plug in the available information and solve for something. Now let's see. A circle has radius such and such. 5 minus 16 is a point on the circle. Radius is 10 units. I am writing down the point again. X-axis is tangent. Y-coordinate of the center is minus 10 because it's below the x-axis. How do I know it's below the x-axis? Because look at the point 5 minus 16. It's below the x-axis. That's one possible diagram that I've drawn. When my answer would come, there would be another possibility which would be in the third quadrant. Let's work for it. Plug in and solve. What are we solving for? We are solving for h. One other thing that I need to emphasize is that even though the y-coordinate of the center is 10, since it's below the x-axis, it's minus 10. So when I plug in the equation y minus k, that actually becomes y plus 10. Is everyone clear on this? Now plug in 5 minus 16. Find the two possible values of h. So a little bit of math. 5 minus h whole square is 64. Don't forget the plus minus 8. Therefore, the value of h minus 3 and 13. Therefore, the possible equations are, this is the first one, that is the second one. So there are two possible equations of a circle based upon two different values of h. And this last question, I think, was the most trickiest one. So we have gone through 8 different questions relating with different geometric properties of the circle. You have to go over it more than once in order to understand it thoroughly. Take care.